Hello, my name is Fiset-Algarvio, and this is Project Digital and Analog Reading and Writing. So first, how this works is I have the traffic light, Jasper's traffic light over here, which with LEDs green, yellow, and red, with the 220 ohm resistor, where the red LED goes into pin 9, the yellow LED goes into pin 10, and the green LED goes into pin 11, and then they all go to ground, or as shown here. Now, first, and I put them in those and the 9, 10, 11 pins because those are all PWM pins. I'll explain why later. Now in the back I have the green wires, long green wires that connect into pin to the 5-volt pin and the ground pin. So that way they are connected into the power rails or power rails on that side because I didn't use this side yet. And then, or you didn't use this side. And now I have it connected. So first off, the button. So I have it connected to the positive on this side, into the button, and then back on the other side, and then into the 10k ohm resistor, back into ground. And I also have another wire from that same place, and that goes into pin 5. And then now I have a LED which starts off from pin 6 and goes into the breadboard through a 470 ohm resistor, and then that goes into the positive lead of the LED, and then the negative lead goes back to the negative rail on the of the breadboard. Lastly, I have the LDR where I have the positive line go through here and then into this 10k ohm resistor, which then goes into this LDR, which is then sent back to negative. And I also have this green wire to send it back to pin A0 on this side. And with the USB cable connected into the Arduino and then connected into the computer. So how it works is first I have the traffic lights simulation where it goes from green to yellow to red, and just like a regular traffic light. Now I have them in pins 9, 10, 11 because those are PWM pins, which means because those pins are analog, so it can be at any brightness you want instead of having the digital of just on or off. And now one thing, that's for the traffic light. Now, if pedestrians wanted to cross, they would have to press a button, and there would be a light. Well, there's the button, and there's the light. So first, the button, if the button is pressed when two of the lights are switches, so like some green to yellow, if the button is pressed, this LED will turn on. And then if the LED is on and it goes back to green, the LED will turn off. So, as a demonstration, so if I press the the button on during that change, the LED turns on, and once it goes back to green, it turns off. So that's for the traffic light from pins 5 and 6. So those are my digital. So if the button is on or off, that's a digital. It'll turn my LED on or off. There's my digital read and write. Now for the LDR, what this LDR does, which is connected to pin A0 on the other side over here, so what will happen, it will set the brightness. So if it's light, if it's bright and everything, well then that means the LEDs would have to be brighter. That way the drivers can see the lights. But if it's dark, like if it's all dark, like the night, it won't be as bright. Like for example, you can barely see it, but it turns just a little brightness that show that it's night. So if I try to take away just a little brightness, you can see that they change. It's much different than if it was in brightness, which is very obvious to see. And that's what I did for my analog. So there's my analog read and my analog write to show brightness. Hello, this is my program for the digital and analog reading and writing. circuit board. So first I've set, for the green LED on the circuit board, I've set pin 11 for green, I've set pin 10 for yellow, and I've set pin 9 for red. I also set pin 6 for the small yellow LED. I set the button pin to 5. I've set the LDR to AO, because that A means analog input. So like, so that's why it's in the AO, because it sends different signals. I've set variables of 1000 for the timer. So it would set a time of, so 1 second is equal to 1000 for a delay. So I've set a timer, so a variable for 1000, and I also set another variable of brightness to 0. Now, those are the input, or those are for naming the pin numbers and values to integers, or variables, my bad. Now, in the void setup, I've set the green, yellow, red, and small LED to output pins, and I set the button and the LDR to input pins. Now, this program will only run once when the program is starts running. So when the program starts running. Now, down here, I have the void loop. So what would happen? It would light on for green for timer 4. So as mentioned above, timer means 1000, so it would go on for 1, and then times 4, so it would go on for 4 seconds. For that's the green, and then it was same for yellow LED, and timer for only 1 second, and then red LED for 4 seconds. And that is how I set digital write of LED pin low. So which means it'll turn the the small yellow LED off. Down here in the subclass, I've set that's called light on. I've set the bright. Now first, so for the first part, like light on green timer times 4 or timer. So I would set the bytes, so the pin number, and then the duration, so the time it would take. Now I've set the brightness would equal the reading of the LDR divided by 4, because the LDR measures a value of 0 to 1023. And then we divide by 4 because it can only write, because like LEDs can only write up to 255. So, and 1023 is roughly, or divide by 4 is roughly, or like almost 255. And then down I have analog write. So it would turn the LED chosen of the LED chosen on above here, and then it would 255 as mentioned, and then minus brightness. Because if I just had brightness, and that means if it was dark, it would go very bright, and in the light, it would go very dark. But then I wanted the opposite of that, so I subtracted the brightness from the 255. And now, if digital read of button pin. So there is the button pin. So the digital read. So if the button was high, so if it was pressed, then the LED would turn high, and then that closes. And that way, it can change from the LED turning on to the delay time. And then now I put the delay as duration of. So duration would be the time given up here, and then up there, and then now for this one, it would, and then what would happen? It would turn whatever LED you asked it to. Once it's done, the duration, the LED that was chosen in the analog right up here would then turn off, which is low, and then it would if read is equal to would do the same thing down here. So if the button was pressed, it was high, then the LED would turn high, and then if the green light has finished, if the green light has finished, the red LED digital write LED would turn low after the green light is turned on. Now I made the subclass because I would have to write like this, that, and that like 3 times, so many times. So if I reduce it, like this. No, actually, no, wait. I would have to repeat all this 3 times. So I just put it in a subclass so I can only do it once. And that is my program. Thanks for watching.